Thanks for tuning in to This Automation Life. I'm your host, Jeremy Schubert. Each week we discuss different technologies used in automation. This week, EJ Takasan, controls engineer and our specialist for circuit breakers at Brenner-Fiedler, is here to discuss circuit breakers. Thanks for joining us, EJ.
Thank you for having me, Jeremy.
No problem. So, I know a little bit about circuit breakers, but I am certainly not the expert. And one thing that I've always wondered is, how do I know when I want to use a circuit breaker versus a fuse?
Well, the basic difference between a fuse and a circuit breaker is that when a fuse is blown, you have to replace it and buy a new one. Where circuit breakers, you can basically reset it and you buy it once and then you can trip it over and over again and have many uses, where a fuse is just a one time and then it's done.
Okay, so that's pretty basic, but they're doing doing the same job?
Exact same job. They're built to protect short circuit or basically your component from frying. So it's just how many times you want to go to the store and replace it, or if it has to be small, then you can use a fuse. But more often than not, you're going to use a circuit breaker because it's cheaper in the long run.
I see. So if you have the space, go with the circuit breaker.
Mm-hmm.
Is one cheaper than the other?
Yeah, fuses are very cheap. You can get like a bunch of them for a couple bucks.
Okay.
Or circuit breakers can be tens to hundreds, depending on how big the current you're trying to protect from.
Okay, well, makes sense. So I know that there's different types of circuit breakers, but I don't know all of them, and I don't know when you would use them. Can you help me out here?
Yeah, there's basically three types of circuit breakers. You got a thermal type, a magnetic type, and a hybrid, which is both of them put together.
Okay.
The magnetic type is basically your fast acting, which basically when you get a short circuit, it automatically trips. And time delay, or the thermal type, happens when a current is in the system for a long period of time and a little bit over current, and then the heat will heat up the breaker and then it'll trip. That's over a long period of time.
Okay.
Now you put both of them together, thermal and magnetic, you get the hybrid, and basically for long periods of time you can protect overcurrent, and also it will also protect during short circuit behavior, I guess.
Oh, are either of these adjustable?
Yeah, they do have adjustable types where you can change the different settings. We'll give you a couple amps difference between 4 to 6. And also they have the fixed ones where you have, at 10 or 15 amps and set at all times. It doesn't change ever.
Interesting. Okay. Wow. So would a thermal type not protect for short circuits? Is that?
Yeah, because the thermal type, okay, if you get into what's inside the circuit breaker, is the thermal type is basically a bimetallic reed inside the circuit breaker that waits to deform after how much time the circuit has.
So electrical energy goes through this thing, it expands or contracts.
And then the circuit breaker trips.
Okay.
Whereas a short circuit, you get a lot of current during a really short time, and that's when the magnetic force is so high that the circuit breaker trips.
Okay, that makes sense. So there's an inertia in the bimetallic material, so it's not going to act very fast.
Mm-hmm.
Cool. Okay.
Right, yeah.
I mean, that's pretty straightforward. Cool. Now, what about when I'm looking at like branch circuit versus main versus, I've heard like supplementary.
Mm-hmm.
Or in other words, what's the differences in all these types of circuits? How do you determine which circuit is what?
Well, your main circuit or your feeder circuit is basically distributing power to all your branch circuits. So if your main circuit power is usually at the top, if you think of a tree, it's at the top, and then each branch or each individual circuit would have like downstream from the main feeder circuit. So every time you have like another motor, or if you have multiple motors, or a light or heater or cooler, each one of those is a different branch. And then each one of those branches need to be protected by its own circuit breaker. Okay. And then everything put together has a main disconnect all the way at the top connected, which is basically your feeder.
So you're only going to have one main circuit breaker.
Yes.
But the branches depend on the type of devices you have.
Yeah, however many types you have. Just like in your house, you have different rooms. Each room has its own breaker because it's a different branch of the house.
But then there's a main for the whole house.
For the whole house.
I see. Okay. Nice. How do you determine which types of equipment need to have circuit breakers? Is that based on standards from regulatory agencies like UL, or is there common practice just from the engineering world?
Yeah, basically, well, for any circuit that you have, you want some sort of protection. All of this is to protect the components you have, so you charge it up and it doesn't destroy itself in the first go around. UL does, for every panel, there needs to be some sort of protection, especially when it gets into high voltage or your house, everything needs to be protected. There's two types actually of protection. There's ground fault interrupters, or GFCIs, and arc fault interrupters. The GFCI, or ground fault circuit interrupters, that protects the components. They don't protect humans. They're there to protect whatever component you're using. And then the arc fault circuit interrupters, that's to protect from fires inside your house.
Interesting. So I guess the other thing that matters is how you size these. So how would you size like a circuit breaker? I know that some of this can be complicated, but is there just a quick kind of rule of thumb?
Yeah, rule of thumb basically is if you're doing a circuit breaker or a fuse, you take the full load amps of whatever component you're trying to protect, and then you double it. That's kind of a rule of thumb. But if you want to go, depending on which circuit breaker you use, if you use a time delay or the time delay or fast acting, they have separate standards on how much you multiply by. And if you want more information, you just go to the National Electric Code 430.52 and get all the information there.
Okay. And what about molded case circuit breakers? I hear that as just as is that a construction thing that makes it different, or why would somebody use?
Yeah. Circuit breakers are all basically the same, but when it comes to the molded case, they follow certain guidelines by UL. Specifically, it's the distances between each line and how protected it is from each other.
To prevent arcing between.
Arcing,
I
exactly.
see. Okay. Cool. Nice. Okay. So what are there different levels of UL that are approved for different types of circuit breakers, or?
Yeah. So going back to that feeder or branch circuit, UL 489 is your main disconnect, or your main feeder circuit would be protected.
Okay.
And then after that, you'd go to different branches, which is either 489 again, UL 489, or UL 508.
Okay.
For motors, they also have to be protected by UL 508. And then after the branch circuit, you can also have supplementary protection, which is UL 1077 for separate,
So if I wanted to protect a PLC or a sensor or something.
Yeah, after.
If I had some expensive device that is more of like an electronics.
Yes.
piece.
So then you'd have like a 489 at the branch, and then underneath that branch, you'd have your supplementary for each device connected to the same.
Okay. Cool. Awesome. Well, that's all we have for this week. Thanks for listening to This Automation Life. Tune in the future as we discuss bearings, working on some actuator podcasts, and designing for FDA. Thanks.